All right, so parameter comes from the question at the top, the proportion of college students that are satisfied with their overall academic experience. Some similar wording.
Would we also have to add that it's during their first year?
Yes, proportion of first year US college students all that are satisfied, that's a lot of words, that's life, with their overall academic experience. And what I hope you do is when you're doing your homework that you read it and you actually write down a statement like this, like what's the proportion we're talking about? Write down the hypotheses and think about what a conclusion would be, how you would write that up. Whereas in homework, you just have those, multiple choice, fill in the blanks. All right, so hypotheses, the null hypothesis would be what?
Equals 75%?
Yeah, P equals, and we'll state it as a decimal is the typical way to write it. And alternative?
P greater than 75?
Yeah, P greater than 0.75. They don't state a significance level, so we'll just do the default. Alpha is 5% or 0.05. Okay, so that's for any hypothesis test, that's the initial setup. State in words what your parameter means, and then write down in symbols what the hypotheses are and pick a significance level. Then we look at the sample. So what do we know about the sample? For the sample, we had a sample size 5,204, and we had 4,122 that yeah, that's pretty good. So for the sample, we've got P hat, which is X over N. X is 4,122, N is 5,204. And what is that number? I think we're ready to just jump into the spreadsheet to start doing this, and then we'll check with stat key. So sample spreadsheets, hypothesis test for a proportion. Let's call it college satisfaction. And for those of you watching this video in the future, I'll put a link to the spreadsheet there. Our null hypothesis is 75% or 0.75. Alternative, and then we don't want a less than there, we want a greater than, and that's only for our reference. The spreadsheet doesn't actually use that information. It's up to us to use it later. And then our P hat equals 4,122 divided by 5,000 something, 520. Anyone write that down?
5204.
204. Sample size is the 520. All right, so those are things I need to enter in to make the calculations to do the hypothesis test. And we're going to try to draw a picture of that in a sec. So let's just make sure I got it right. Sample size 5,204. Successes is 4,122 for students who are satisfied with their first year experience. All right, I think we got all the information in the spreadsheet. Let me screenshot this and try to draw a picture of it. Oh, actually, I'm going to adjust the number of decimal places. Increase. Wow. Okay. Cool. Did I calculate this right? I think so. All right, so let's try to draw a picture of what this tells us. Add to new page. All right, so here's your goal right now. Sketch a normal distribution. Where does our p-value end up in the sketch based on this information right here? And this is the part that I want you to turn in, the sketch that we're about to create. So for a hypothesis test, the null value goes in the middle. So that would be P is 0.75. And then based on this Z, oops, whoa, what just happened there? Weird. Based on this Z score over here, I have to place my sample statistic. I think it's a little off the graph. Yeah, so think about it. When we count by standard deviations, typically one standard deviation is about there, 2, 3 is about here. We have a Z-score of 7 standard deviations. Oh, to the right, I'm going the wrong way. So 1, 2, 3, 4, 5, 6. It's at least way out there. So that would be a Z-score of about 7-ish. So that would be Z equals 7. In the middle would be Z equals 0. That's Z equals 1, 2, 3, and so far, right? And, oops, this should be Z equals 7 out there. I'm trouble writing today. 7-ish. And that goes with our 79% of students found it a good experience. So that's our P hat. It's about 0.79-ish. Okay, so what a hypothesis says to us is the null value very far from is the sample value very far from the null value? Sometimes it is and sometimes it isn't. Like with the mixed nuts, they weren't far apart. Here, the Z-score says they are very far apart. To say it's more like 75% is an understatement. Way more than 75% of first-year students were satisfied. For a sample size of 5,204, 79% is way higher than 75%. They're not in the same ballpark. According to the spreadsheet, our p-value was essentially 0. It couldn't even compute it. It was so small. In stats, we usually call that 0+. It's never exactly 0, but it's immeasurably.
I probably missed this, but did we have an X to divide by or?
Yeah, so back in the notes, the page back here, I wrote that down. So our X was the 4,122 students who said they had a good first year experience out of a total of 5,204 students. Yeah, and that's in the spreadsheet. I just typed it as a fraction. I didn't do them separate. So in this line for P hat, I just typed equals 4,122 divided by 5,204. And that gave us a little tiny standard error, 0.006, and a huge Z-score. So again, what I'm looking for when I'm running a hypothesis test is the Z-score close to 0 or is the Z-score far from 0? If it's close to 0, then the sample is like what the null set it should be. If it's far from 0, then the sample is very different from what the null set it should be. Okay? And here we're finding that it's significantly more than 75%. Okay, so again, the sketch based on what the spreadsheet's telling me here is this right here. In the middle is the 75% that the null hypothesis was aiming for. The Z-score of 7 means our sample statistic of 79% is way, way, way to the right, and the p-value is immeasurably small. And the decision here is to reject the null hypothesis. Reject null. So I would like a sketch of that from you. So the sketch includes the null value, the sample statistic, the Z-score, and the p-value. All of those things should be in your sketch. Null value, sample statistic, the Z-score, which is also known as a standardized test statistic, and the p-value. So next thing we need to do to back this up is run a stat key randomization and see if it matches. Questions on what we have here from the spreadsheet? All right, so jump over to stat key. And then double check, I want hypothesis test for a proportion, and we just have one proportion. And then we edit in our data. That was the 4,122 divided by the sample size of 5,204. And that should give us our 79.2% over here. And then what should our null hypothesis state? 0.75. Yep. So once you have your sample data in there and you have your p-value set, then you can start generating thousands, 7,000 schools today. Based on the alternative hypothesis, we're doing a right tail test. And then I need to plug in my sample value, which is 0.792. To get the p-value, woo, way off the chart. Z-score of 7. Not even close to the mean of what the null says it should be. Every hypothesis test is different. Okay, so that kind of matches the sketch I made. It's a little taller, but it's okay. It's the same kind of spread that I was drawing in mind. Okay, so does stat key back up what the spreadsheet was telling us? Yep, it's given a p-value of 0. The only thing stat key doesn't do is show the z-score. So I just want to remind you about that z-score. And then we are done for the day. We've kicked butt on section 6.1. To calculate a z-score to go with this, for a proportion, it's the sample statistic minus whatever the null hypothesis says. The book calls that a p0 for null. I just call it p. And then divide by the standard error. How do we get the standard error? Standard error was that crazy square root. P times 1 minus p over n. And the spreadsheet was designed to just do that for us. Stat key doesn't make that calculation. It does it with its magic card shuffling program. And they give similar results. Let's just double check the standard error. According to stat key, the standard error is about 0.0059. And according to the spreadsheet, it was 0.006. Yeah, they're about the same to the nearest thousandth. Okay. Cool. Questions? Okay, so here